Hello, so in this video we're going to look at chapter 6.3, factoring special products. So there will be 3 special cases that we'll be looking at, and also in the description below there will be the video chapters in sections so you can jump to certain topics that you want to see. There will be the links to the first and second edition of the Intermediate Algebra textbook, a shared folder with additional resources and handouts that you're welcome to look at, and at the bottom there will be a survey. So let's first look at factoring perfect square trinomials. And so the way we would do these, we would start on this side and we would go this way. And so we're going to find our a and b's just by looking at the equations or the polynomials, and we will put them in the form over here depending on what sign we are given on the polynomial. So first we're going to look at 9x squared plus 12x plus 4. And so we can see that we have our a being 9, and in this case when we're doing the special products, our b is actually 4. And since we're looking at perfect squares, for 9x squared we would put it as 3x squared, and for 4 being a perfect square we would put it as 2 squared. And so remember from the patterns that we were looking at, or the formulas that we were looking at, this pattern would fit a squared plus 2ab plus b squared. And so if we look at rewriting it, our equation, we could rewrite it as 3x squared plus 3x in parentheses, and in parentheses 2 plus 2 squared. And so our answer would be 3x plus 2 in parentheses squared. So next we're given 64m squared minus 16m plus 1. And so since we fit the pattern of the second one, where we have a squared minus 2ab plus b squared, and we can see that our a being 64 and our b being a positive 1. So for a, we would have a 8m in parentheses squared, and for 1 we would just have a 1 squared. If we put it back into the formula that we're given, we would have 8m in parentheses squared minus 2 in parentheses 8m, and in parentheses 1 plus 1 in parentheses squared. And so our answer would be 8m minus 1 squared. So in this one, we're given 64x squared y plus 96xy plus 36y. And so we would first want to look and see if we have a greatest common factor. Pulling out our greatest common factor being 4y, we would be left with 16x squared plus 24x plus 9. Now we can see that it would be a perfect square, our a being 16 and our b being 9. Our a 16x squared would equal a 4x in parentheses squared, and our b 9 would equal a 3 in parentheses squared. And so since we fit the pattern of the first one, a squared plus 2ab plus b squared, if we put those into the formula, 4x squared plus 4x in parentheses 3 plus 3 squared, our answer would be 4y in parentheses 4x plus 3 squared. So next we're going to look at factoring different square trinomials, and in this idea both the a and the b will be squares, and you'll write it out as a plus b, a minus b, both in parentheses. So for the first one we have 25v squared minus 1. We can see that for 25v squared the perfect square would be 5v in parentheses squared, and for 1, it would just be 1 squared. And so since it fits the form as well, because we have to have a minus right here to work, if we had a plus, it would not matter. We couldn't do anything with it, and we would just leave it the way it is. So our answer would be 5v minus 1, 5v plus 1. For the next one, we have 98r cubed minus 72r. We could pull out a 2r being in common, and we would be left with a 49r squared minus 36. And 49 and 36 are both perfect squares. 49r squared would equal 7r squared, and 36 would just equal 6 in parentheses squared. And since we fit the form as well, we would have our answer as 2r, 7r plus 6, 7r minus 6. Now we're given 48m to the 4th n squared minus 243n squared. And we want to look at the sum of difference of squares, and we can see that we can pulling out a 3n squared, we get a 16m to the 4th minus 81. And we can see that we have perfect squares now. And so 16m to the 4th we can write as 4m squared, in parentheses squared, and 81 we can write as 9 squared. We can put in the form 3n squared, 4m squared minus 9, and 4m squared plus 9. But since we still have another difference of squares, we can keep going. And we can see that 4m squared would equal 2m squared, and 9 would just be 3 squared. And so our answer would be 3n squared, 2m plus 3, 2m minus 3, and 4m squared plus 9. So now we're going to look at factoring the sum or difference of cubes. And so now we're going to go this way. So a and b will be cubes, and we have to, like if we took the cubed root of that value, then it would work. So we're going to do that in the process, and then we can plug it into these two formulas, and we will get a polynomial and a binomial together. So first we're given 9 to the 6th plus 512. So first we can see that it is a cubed root. If we take the cubed of each, we would have n squared cubed, and 8 cubed is 512. And so if we add it to our formula, so we have a plus b, and a squared minus ab plus b squared. We have a being n squared and b being 8. So we have n squared plus 8, and then n squared squared plus n squared 8 plus b 8 squared. If we do all the calculations, we get an n squared plus 8 in parentheses, and n to the 4th minus 8n squared plus 64. For the next one, we have 6x cubed minus 48y cubed. If we pull out a common factor of 6, we are left with x cubed minus 8y cubed. If we looked at taking the cubed, we can do x cubed minus and 2y would be cubed. And so we put it into the formula. We have a minus b in parentheses, and then a squared plus ab plus b squared. Putting it in there, we have 6 in parentheses x minus 2y and x squared minus, or excuse me, plus 2y x plus 2y squared. And if we do all calculations, we get an answer of 6 x minus 2y x squared plus 2xy plus 4y squared.